Welcome back. This is Mr. Greenstein's Geometry, and we're talking about Chapter 8. This is Section 8.2. We're going to be proving triangle similarity by angle. So there's a theorem that says that if you have two triangles, and one triangle has two angles that are congruent to two angles of a second triangle, then the triangles are similar. So in this particular case, I have angle A and angle D are congruent. Angle B and E are congruent. And once I'm shown that, then I know that the two triangles are similar. So let's take a look at these two triangles. Are these two similar triangles? Well, I have one angle 70, one angle 38. The third angle has to be congruent because I have a third angles theorem, which says that if two angles are congruent in one triangle to two angles in a second triangle, then the third angles must be congruent. So all three angles are the same. But in angle-angle similarity, we only have to show that two angles are congruent. So we have our 70s, we have our 38s, so yes, these two are congruent. What about these two triangles? I have the big triangle, ABCD, and then I have the smaller triangle, AED. Are these similar? Well, let's just take a look. I have parallel lines here, and when I have parallel lines, that means that a number of angles are going to be congruent. Like this angle here, AED, is going to be congruent to this angle B down here because they're corresponding angles. And the same thing with this angle here and this angle here. But I also have a shared angle A up here. So if I can just show that A is congruent between the two triangles, which I can because of the reflexive property, and I just have to find one more angle. Well, I have this angle here and this angle here. Therefore, this little triangle up here is congruent to this big triangle down here. Now let's actually do a little bit of calculating. If I say that this triangle up here is, let's see if it's similar to this triangle down here. Well, I have this common angle between the two triangles, and then I have this angle is congruent to that angle. Angle-angle similarity. Therefore, if they're similar, then all the side lengths have to be proportional. So let's figure out what x is. If I look, the small triangle has a side length of 4 on this side. The corresponding side for the larger triangle is this whole side, which is length 6. So we have 4 is growing into 6. So then it's going to be 6 over 4, or another way of saying that is 3/2. So that's our k, and that's how long, that's our scale factor that we're going to be using. So now I can take x and I can say, well, the scale factor is going to be 6 going up to k, and what I do is I just take 6 and multiply times 3/2, and that's going to get me 9. So x is equal to 9. In this next problem, I have a small triangle up here, and then I have my bigger triangle here, and I want to find out what AB is. So to find out AB, I'm going to use this side as corresponding to that. So my scale factor is going to be, I'm going to be going from 24 up, I'm going to be going from 24 up to 6.5. So 6.5 will be on the numerator, and 24 will be on the denominator, and that's my K factor, my scale factor. For this line here, A to B, I have an unknown quantity BF. So if I want the whole length of AB, I have to add up both the 17 feet plus the distance BF. And I'm going to compare that to BF. So I'm going to say that I have BF on the top, and that compares to 17 plus BF. And that should equal my scale factor. Once I have that, then I can just put these two formulas together and make them equal to each other, and then solve for BF. And once you've done that, then we'll talk about the results tomorrow in class. Let's look at this last problem here, and this is what is called the mirror problem. We have a flagpole, which is, we're going to say that this forms a 90-degree angle with the ground. So we're going to say that it's a right angle with the ground. And we're also going to say that we have a person over here that forms a right angle with the ground. So there's going to be a right angle here. So we have two right triangles, and the ray of light is going to be the thing that is going to create the third side to our triangle. So here I have the flag, I have the ground, and then I have this ray of light that's coming in like this. It turns out that the physics of a ray of light hitting a mirror, and this is a mirror, the incident angle of incident is the same as the angle of reflection on this side. Therefore, I have congruent angles here. And using angle-angle similarity, then since I have two angles congruent to two angles over here, then this triangle and this triangle are both similar triangles. Therefore, the distances are going to be proportional. I can figure out what the distance is, the height of the person. So the height of the person, I'll call it little h, and I want to compare that to the height of the flag, which is big H. The thing about the flag is I can't measure that easily because I don't have a ladder to do it. But I can measure the person very easily. Also, I can measure the distance on the ground here, that's not hard, and the distance from here to here on the ground. And when I do that, then I have my K factor, because the distance from here, I'll call this big D, and then this is little d. If I take big D and divide by little d, that's the same thing as saying big H compared to little h. And the ones that we know that we can find is that we can measure this, we can measure this, and we can measure this. This is the one that we cannot measure because we don't have a ladder for it. But we can calculate it by filling in all the rest of this formula. And once we do that, we can find the height of the flagpole using angle-angle similarity. So that concludes this section, and we'll talk about this in the next day. Let's just take a look here at some samples. And why don't you do a calculation, remembering that there are 12 inches in a foot. And we'll talk about this tomorrow.